On comparing the ratios A1 upon A2, B1 upon B2 and C1 upon C2, find out whether the following pairs of linear equations are consistent or inconsistent. Let's take the first problem. So our first problem is 3x plus 2y equal to 5 and 2x minus 3y equal to 7. So we need to compare it with our standard or general form of linear equation, which is in case of this we'll take it as if we take this as a1x plus b1y plus c equal to 0, then in this case this will be a, so this will be a1 which is equal to 3, this will be b1, okay, put it over here, b1 equal to 2, and since this is on the other side of the equal to sign and this is positive, and in this case it is on the left hand side of the equal to sign, which means if we bring 5 on the left hand side then it will become negative, so that means c will be equal to negative 5. Similarly over here, if we compare this to a2x plus b2y plus c2, over here c1, then this is c1 equal to 0, then in this case a2 will be equal to 2 and b2 will be equal to minus 3 and c2, since this is positive 7 but on the right hand side of the equal to sign, when we bring it to the left hand side of the equal to sign it will become negative, so c2 will be equal to minus. Now that we have got a1, b1, c1 and a2, b2, c2, let us compare it in the ratios that we have been given. What is a1 and a2? We'll write that down first. So we put a1 upon a2 which is equal to 3 upon 2. So b1 upon b2 is equal to, what is b1? 2. b2 is minus 3. Okay, and c1 upon c2 we get as c1 is minus 5 and c2 is minus 7. So this minus and minus cancels out and we get this as equal to 5 upon 7. Okay. Okay, now that we have got this into ratios, always first compare a1 upon a2 to b1 upon b2. So let us see. a1 upon a2 is 3 upon 2. Is it equal to, and I'll take this negative sign on top because we should not keep negative sign in the denominator, we should always take it to the numerator. So if you see over here, this is a1 upon a2 and this is b1 upon b2. They are definitely not equal to each other. In that case, this implies that a1 upon a2 is not equal to b1 upon b2, which means that we have got, okay, therefore this means that this is a unique solution and it means that this pair of linear equations is consistent. Our next problem is 2x minus 3y equal to 8 and 4x minus 6y equal to 9. So if we compare this, we can take this as a1 will be equal to 2 here, b1 will be equal to minus 3, c1 will be equal to minus 8 because it will come on the left hand side and become minus. Then what about a2? So in this case a2 will be equal to 4 here, b2 is equal to minus 6 and c2 will be equal to minus 9 when 9 is brought to the left hand side. And now we compare a1 and a2 to b1 and b2. Okay, so a1 upon a2 can be written as 2 upon 4 and b1 upon b2 can be written as minus 3 upon minus 6. Okay, now we cancel this 2 1s are 2, 2 2s are 4 and we cancel the minus sign over here and 3 1s are 3, 3 2s are 6, which means we get half is equal to half, which is nothing but it means, so this implies that A1 upon A2 is equal to B1 upon B2. But now let's see if B1 upon B2 is equal to C1 upon C2. So B1 upon B2 is, we've got minus 3 upon minus 6, and C1 upon C2 will be minus 8 upon minus 9. So clearly it is not equal to C1 upon C2. So we say B1 upon B2 is not equal to C1 upon C2. So we have A1 upon A2 is equal to B1 upon B2 but is not equal to C1 upon C2. So in this case we have no solution. Okay, so this implies that there is a linear pair of, I can say, pair of linear equations has no solution. Okay, and this means that it is inconsistent. Okay, it is inconsistent. So our next problem is 3 upon 2x plus 5 upon 3y equal to 7 and 9x minus 10y equal to 14. So we can either take this 3 upon 2 as A, or we can get the LCM of this. Let's get the LCM to make it easier. So over here, that means the LCM 3 into 2 will be 6. So we multiply throughout by 6. So if we multiply throughout by 6, this is what we get. 3 upon 2x plus 6 into 5 upon 3y into 6 into, equal to 6 into 7. So 2 ones are 2, 2 3s are 6, 3 ones are 3, 3 2s are 6, and this will remain 42. So 3 into 3 we get 9x plus 2 into 5 10y and equal to 6 into 7 42. Okay, so this we get our first equation, and this is our other equation. Now let's compare this to our general form. So A1 will be equal to 9, B1 will be equal to 10, C1 will be equal to minus 42 when the 42 comes on the left hand side. And in this case you have A2 equal to 9, B2 equal to minus 10 and C2 equal to minus 14. When it comes on the other side, on the left hand side, 14 becomes negative. Now let us compare A1 upon A2 to B1 upon B2. So A1 upon A2 is, A1 is 9, A2 is also 9, and you have B1 which is 10 but B2 is minus 10. So obviously this will cancel out, 9 ones are 9 over here, and 10 into 1, 10 ones are 10, it will cancel. So you'll get 1 upon 1 which is equal to, we'll take the negative side on top in the numerator, and this is minus 1 upon 1. So obviously this is not equal to this, so which means that A1 upon A2, so you can say that this implies A1 upon A2 is not equal to B1 upon B2. You don't have to go further to check whether B1 upon B2 is equal to C1 upon C2. Once you get that A1 upon A2 is not equal to B1 upon B2, stop there, because this will tell you that therefore you can say the pair of linear equations is consistent. Okay, and if you get this condition, that means you have, it is giving you a unique solution. So pair of linear equations has a unique solution. Okay, unique solution, and it is consistent. Okay, it is consistent. So again, if you get A1 upon A2 which is not equal to B1 upon B2, then do not go further to check whether B1 upon B2 is equal to or not equal to C1 upon C2. We have satisfied this condition, and when these first two are not equal to each other, that means we get a consistent solution, or we have a unique solution. Okay, let's move to the next question. Okay, the next question is 5x minus 3y equal to 11 and minus 10x plus 6y equal to minus 22. A1 equal to 5, B1 equal to minus 3 and C1 is equal to minus 11. Similarly, we have A2 equal to minus 10 since it says minus 10x, B2 is equal to plus 6, and C2 will be positive 22 because minus 22 when it comes on the left hand side the sign changes to positive, so positive 22. Let's compare A1 upon A2 to B1 upon B2. So A1 is 5 and A2 is minus 10 and B1 is minus 3 and B2 is 6. Okay, so in this case 5 ones are 5, 5 twos are 10, 3 ones are 3, 3 twos are 6. Okay, I will take the negative side on top. So 3 ones are 3, 3 twos are 6. So you have minus half here as well. Okay, so that means the two are equal to each other. This implies that A1 upon A2 is equal to B1 upon B2. Now that they are equal, the ratios are equal, let's check whether B1 upon B2 is also equal to C1 upon C2. So we will do this over here. B1 is minus 3, B2 is 6, C1 is minus 11 and C2 is 22. So 3 ones are 3, 3 twos are 6, 11 ones are 11, 11 twos are 22, which means we get minus half equal to minus half. So which means that B1 upon B2 is equal to C1 upon C2. Okay, now this total thing implies that A1 upon A2 is equal to B1 upon B2, which is equal to C1 upon C2. So therefore we can say that pair of linear equations is not only consistent but also dependent on each other. So pair of linear equations is or are dependent and consistent, okay, because they give you infinitely many solutions. Okay, so here you have A1 upon A2 is equal to B1 upon B2 equal to C1 upon C2. Let's go to the final problem. So our final problem says 4 upon 3x plus 2y equal to 8 and 2x plus 3y equal to 12. So in this case what we'll do is, to get rid of this 3, we'll multiply this entire equation with 3 throughout. So that will be on both sides. So we'll take 3 into 4 upon 3 x plus 3 into 2y equal to 3 into 8, and 3 and 3 will cancel, we get 4x, 3 into 2 is 6y equal to 3 into 8 is 24, and here we have this. So let's get our A1. A1 is 4, then we have B1 equal to 6 and C1 will be equal to minus 24, and here we have A2 equal to 2, B2 equal to 3 and C2 equal to minus 12. Let's compare A1 upon A2 to B1 upon B2. So A1 is 4, A2 is 2, then B1 is 6 and B2 is 3. Okay, so 2 ones are 2, 2 twos are 4, 3 ones are 3, 3 twos are 6. So that means we have 2 upon 1 equal to 2 upon 1. Okay, so this implies that A1 upon A2 is equal to B1 upon B2. Let's check whether B1 upon B2 is equal to C1 upon C2. So what is B1? B1 is 6 and B2 is 3. C1 is minus 24 and C2 is minus 12. So 3 ones are 3, 3 twos are 6, minus and minus cancels, 12 ones are 12, 12 twos are 4. That means 2 upon 1 is equal to 2 upon 1. This implies that B1 upon B2 is equal to C1 upon C2. So this entire thing implies that A1 upon A2 is equal to B1 upon B2 is equal to C1 upon C2. And hence we can say that the pair of linear equations are not only consistent but they are dependent on each other, and also the fact that they have infinitely many solutions. This is all about finding whether the pair of linear equations is consistent or not, and whether they give you infinitely many solutions or just a unique solution or no solution at all. Thank you for watching.